Hey guys. All right. So we are skipping lesson 4 and we're skipping lesson 3 and going straight into lesson 4. So hopefully that last video was helpful. I've been having a lot of technical difficulties on my end, so I'm hoping everything worked. So in lesson 4, at the top of your page somewhere, find some room, pause the video, and write down these goals for this lesson. So our first goal is we're going to describe the shape of distribution. Okay, you're going to hear me say the shape of the distribution a lot. Okay, that just basically says what the graph looks like, whether it increases, whether it decreases, whether it stays the same. That's what I'm talking about, how all the data is distributed out on the graph. Okay, and we're going to be using these words. We're going to be using symmetric, skewed, uniform, bimodal, and bell-shaped. Okay, those are all words to describe distribution. So we'll get into more about what those mean. And then we're going to be looking at graphs and talking about what they mean in the real world context. So why is it important that it's bell-shaped? What does that tell us? Why is it important that it's bimodal? What does that mean in its real world context? Okay, so we're on pause real quick. Oh my goodness. Okay, I had all of that on my lesson 1. Okay, now we're rolling. Okay, same stuff. Okay, so we're on 4.1, and we're doing another which one doesn't belong. Okay, so again, you're basically just going to be comparing all of these different graphs. Okay, maybe what does some of them have in common? What are different about some of them? Okay. And then you're going to determine which one doesn't belong. So take about a minute, look what time it is on the clock, pause the video, be honest, actually do it, and then come back. And we obviously won't talk about it. I'm just going to put all the things that I noticed. Okay, so here we go. As I'm looking through these, and I'm looking at A, if you chose A that you thought didn't belong, because compared to the other ones, it's the only one that increases and decreases, decreases. That's also symmetrical. Okay, meaning that if we drew a line about right down in the center, it's going to be very similar on both sides. Okay, it's not going to be exactly the same. Okay, because I see there's a little dot over here. But overall, it's going to be symmetrical. Okay, so it increases and it decreases. Okay, I want you to notice it goes up and then it comes down. Okay, so maybe that's why you chose A. Okay, well, some of you may have chose B because it starts off increased and then it decreases and increases again. So it kind of goes the opposite. It decreases, then increase. No, I'm sorry. It then decreases and then increases again. Sorry. Yeah, I was right. Okay. This one is also symmetrical. So like A, if we symmetrical, I don't know. Don't look at my spelling. If we were to do it in half, then it's very similar on both sides. So that's what symmetrical means. Okay. All right, the next one also, it's the same the whole way, okay? We could say it's even constant, meaning that it's just straight across, same data, like it doesn't change, okay? So you might have said C was the one that didn't belong because it's the only one that doesn't change, okay? And then finally, you might have said this last one, D, because it's got like this little tail over here. So it kind of stays the same. And then all of a sudden it increases and then it decreases. Okay. So you might have said it doesn't belong because of that shape. Okay. So if I'm looking at all of them all together, I can tell that there is something about each one that's kind of different. Okay. So going back to our goal at the beginning, there's actually words to describe how each one of these graphs are shaped. And then based off of how the graph is shaped can tell us so much information about the data that it's showing. Okay, so this first one, we talked about how it starts off like it's increasing and then it kind of peaks and then it starts decreasing. That graph is actually called a bell-shaped graph. Okay, so write that down. All right, so there's a lot of characteristics about things that are bell-shaped where it's basically one of the things is that the majority of the data is right here in the center. Okay, it's all kind of right there in the middle, and that's going to be really important to know later on. It's called bell-shaped because if I were to do like this, you know, and draw a little bell, you know how a bell looks. That kind of looks like a little bell you ring, okay? That's why it's called that. Okay, so there's one of the little things, bell-shaped, symmetric. Okay, so they're symmetric again, but this one's a little different. It almost looks like the opposite of a bell curve, but that's not what it's called. Okay, this one, it has these two like tall points at the top, on each side. Okay, so it's you can see on this one, the majority of the data is on these outsides as opposed to the middle, like in the bell-shaped. All right, so these two little increases on each outside of the graph, those are called peaks. Okay, so you can label those. All right, so we can see that there's two peaks in this one where it gets really high and then it low, like kind of decreases and then it gets really high again. This one's actually called bimodal. This is a bimodal graph. Okay. A way to remember that is the word bi, the prefix bi, that means two, like a bicycle. It has two wheels. A bimodal graph has two peaks. Okay? And it's not always gonna, bimodal graphs aren't always symmetrical. It's really just kind of pointing out those peaks that it has. Okay? So there is the bimodal one that we talked about in our goal. All right, we have two more that we haven't talked about yet. All right, so let's look at C. So we have this graph that stayed the same, it stayed constant the whole time. There's actually a name for it. It's called uniform. Okay, and I remember this one, uniform, like as if I were like in the army and I see all the army men in uniforms and you know how they have to walk in those straight lines and in those straight rows. Okay, and it's very much the same and constant. Okay, that's how I remember these graphs. Okay, because it looks like you just have a bunch of army men in rows and it's like perfectly in line. Okay, but if I had a graph that was like exactly like this, but like these last two, maybe had like two more, overall, it's still pretty uniform. So you would still consider that a uniform graph, even though it may have like one or two dots here and there off. All right, so this last one, I'm gonna let you take a wild guess and see what its name is. This one is actually, because it has this tail, where the majority of the data is just on one side. And then like on the other side of the graph, it's very thin and it has like almost like this tail of just like random pieces of data. This one's called skewed. Okay, when you see that something's skewed, it's almost like it's like moved over a little bit or like pushed to the side, okay? That's what skewed means. So when you see a graph that looks like this, and it has the majority of the data off to the side and then just like a little bit of random data kind of like off to the other side, that's going to be skewed data. And that's going to be important to know because skewed data, it's going to tell us a lot of other stuff about the data, about whatever information we're looking at. Okay, so those are all the different types of graphs. And it's going to be really important that you remember those vocabulary words and know later on what those types of graphs tell us about the data that we're looking at. Okay, so we're going to kind of skip ahead. This is like almost at the very end of this lesson. It's the Are You Ready for More? Because the other assignments required y'all to like sort and do all the stuff, which we, one, can't do over the computer, and two, we couldn't do in person either because we can't all touch the same stuff. So here we are. So it says this distribution shows the length in inches of fish caught and released from a nearby lake. Okay, so that's what this graph is talking about. Okay, first thing, I want you to take like a little bit of time, pause the video, and try to do your best to answer these questions on your own. Okay, it doesn't matter if you get them right. Okay, it matters that you attempt them, do your best, and then come back and then let me talk you through it. Okay, so the first thing says describe the shape of the distribution. So remember, that just tells you how your graph kind of increases or decreases or whatever. Okay, so hopefully you've paused and you've already answered this and now you're listening to the actual answer, but to see how you did on your own. Okay, so the first thing I noticed, and you could have put, is you could have put something like, I'm going to type because it'll go a little faster. Oops. You could have said the graph increases, then it decreases, then increases, I can't spell, and decreases again. Okay, that is not a wrong answer because that's what's happening in it. Okay. Something else I noticed that, like what we talked about with our vocabulary earlier, is I have these two very high points of data. And if you remember what those are called peaks. All right, and what's that graph called when we have more than one peak of our graph? It's bimodal. So for that one, you could describe it this way. If you're like being very descriptive, it increases and decreases and increases and decreases. Okay, or you could say it's a bimodal graph. Okay, and as we move forward in this unit, that's going to tell you a lot more than you think about the information, about the data. Okay, and this one says make an educated guess about what could cause the distribution to have this shape. So there could be a lot of different reasons for this, and you may have all come up with really good responses, but obviously I can't hear what your responses are, so just because mine is more than likely going to be different than yours, just because there's a lot of different reasons for it, doesn't mean yours is necessarily wrong. So maybe just like put a little line or something and write this response that I have. So it says, like I said, it said make an educated guess. So we need to remember what we're talking about. We're talking about the length in inches of fish caught and released in a lake. So according to our data, the length of the fish start out really small, and then they get longer, and then some are shorter, but still, I mean, stop myself. Okay, so we caught a couple of fish. Who knows how many, because this side isn't labeled, but let's say that's one fish that was it was really short. Then we caught a few more that were longer, a few more that were a little longer, a lot that were really long, and then we caught fewer that were longer, and we could see that they range from all different lengths, but we caught more of certain lengths. So the higher they go up, that means we caught more of that length fish. Okay, so we know that when we go to a lake or a pond or whatever and go fishing, every single fish isn't the same length. Okay, so one of the reasons is you could have said every fish in the lake isn't the same length. That's why there's all those different lengths in it. Okay, or you could have said there are many different types of fish in the lake, so they aren't going to be the same size. Okay, something like that. The purpose of that question is for you to take this graph that It just shows you barely any information at all, and think about it in a real world context, which is what our goal was from the beginning. It's just being able to look at it and think of it in a real world situation, okay? Even though those answers seem kind of like, duh, that's obviously what it is talking about. But when you first look at it, you may not see that, okay? So that is that. Let's look at the lesson summary, and then we will be done with lesson 4. All right, so there is a lot to this summary because we, believe it or not, talked about a lot of information that's going to be expanded later. So let me zoom in. You need to have a highlighter so you can highlight this, or a pen or a pencil or something to underline so you can follow along in your book. All right, so it says we can describe the shape of distribution as, we can say it's symmetric, skewed, bell-shaped, bimodal, or uniform. Here is a dot plot, histogram, and box plot representing each one of these distributions of the same data set. This data has a symmetric distribution, okay? So we can see it's symmetric because if we were to draw a line down it, it's going to be pretty even on both sides, okay? Even though we can see this histogram's kind of wonky, but that's, remember, because we group it into different intervals. So it's going to be a little different, okay? So symmetric distribution, when you're looking at this, it's talking about the mean is equal to the median, and there is a vertical line of symmetry in the center of the data set. All right, we're going to get into the mean is equal to the median later on, and we're going to be talking about what that means and kind of expanding on it probably in the next lesson. This distribution in particular can also be called bell-shaped. A bell-shaped distribution has a dot plot that takes the form of a bell with most of the data clustered near the center and fewer points farther from the center. And finally, bell-shaped distributions are always symmetric or close to it, okay? So you can see up here when you do that, these are also bell-shaped. Now with box plots, you can't really see that bell shape because it's just how box plots work. Okay, so now we're going to be looking at this. This is a skewed distribution. Okay, so you can see how the majority of the data is chunked near one end, and the rest of it has like this skinny tail that's kind of going out of it. Okay, that's what a skewed distribution looks like. So skewed distribution, one side of the distribution has more values farther from the bulk than the other side. This results in the mean and the median not being equal. So we talked about up here, the mean is equal to the mean in a symmetric and a bell shape, but in a skewed, they are not equal. You can't even see that. I don't know if that's any better. Oh, whatever. Y'all know what I'm saying. All right, blah, blah, blah. The mean is greater than, I'm gonna erase that because it's not always true. The mean is greater than the median for distributions that are skewed to the right, okay? So you can tell which way it's skewed based off of the tail. So since the tail is on the right side, this one would be skewed right, okay? Next, we talked about a uniform distribution. The data values are evenly distributed throughout the range of the data. This causes it to look like a rectangle. In a uniform distribution, the mean is equal to the median. since the uniform distribution is also symmetrical. It does not, the box plot does not provide enough information to describe the shape of the distribution as uniform enough, even though the length of each quarter does suggest that it is. And finally, let's do a purple. We have a bimodal distribution. It has two very common data values seen in a dot plot or histogram as distinct peaks. Okay, so we talked about how there's one of our peaks and there's one of our peaks. Here's one of our peaks, here's one of our peaks, and those are really easy to see in our graphs. Sometimes a bimodal distribution has most of the data clustered in the middle of the distribution. In these cases, the center of distribution does not describe the data very well. Bimodal distributions are not always symmetrical. For example, the peaks may not be equally spaced from the middle of the distribution, or other data values may disrupt the symmetry. And that's kind of like what we saw earlier here. We had the bimodal, but it wasn't exact. I mean, it's pretty close, but this one wasn't exactly symmetrical on both sides. Okay, now, if at any point you need to go back and pause the video so you can get all that highlighted, please do it. If you have any questions, I'm going to be back, so don't stress. We're going to get it, okay? And we're going to talk about this more as we move forward. This lesson just had a lot of information in it. Okay, bye, guys.